Good evening, ladies and gentlemen. This is your well-rounded math teacher, Mr. Bakar. We're doing the second half of the notes here, so the second video for Unit 7-6, analyzing graphs of polynomial functions. And once again, we're going to be talking about locating real zeros, maximums, and minimums, and we're going to be using synthetic division to do that. So let's go to number 2 on the back. Here we go. It says graph the polynomial function f of x equals x cubed minus 4x squared minus x plus 4. This is a cubic, so it should have 3 zeros. Given the first one is x equals 4, we can find the other two. But first of all, let's get this out here. Zeros. Well, we know one of them is x equals 4. So I'll put that in there right away. Let's see if we can find the other two. So using synthetic division, 4 is my first zero. This looks like it's in degree of decreasing order. X cubed, x squared, x to the first, and then no x, just the 4. So listing those coefficients, 1, -4, -1, and +4. We can use synthetic division to break this down and then find our other zeros. Okay, so bringing down the 1 first. Multiplying by 4, I get 4. Adding the columns up, as always, I get 0. 4 times 0 is 0. This gives me -1 when I add the -1 and the 0. And then I get -4. Adding this column up, I get 0. This is my remainder. So it divides in there evenly. Now, it started out, we were dividing into an x cubed, so this 1 here, 1 degree less than that, would be x squared, so that's 1x squared, plus 0x right here for the 0, and then just -1 equals 0. So to find our other two zeros, we factor this. 1 is a perfect square, x squared is a perfect square. You're subtracting, so it's difference of perfect squares. This is x and x. 1 and 1, but it's +1 and -1. When you multiply the 1 times the -1, you get -1, and that's what we want. So there we go. Now to actually get our zeros, we just set our factors equal to 0. First of all, x plus 1 equals 0. Subtracting 1 from both sides, I get x equals -1. And then x minus 1 equals 0. Adding 1 to both sides, I get x equals +1. So the other two zeros, to go along with the first zero, I think, which was 2, is -1 and 1. Actually, there's 4. So we also have x equals 1 and x equals -1. So there are 3 zeros. Excuse me. Graphing them now, 4 is one of the zeros, 1 is another 0, and -1. And we can kind of rough in our graph now because our leading term here, x cubed, it's 1x cubed, that's positive, so being it's a cubic, it's going to have to look something like this. My end behavior on the right hand side is x is approaching positive infinity. F of x has to be positive also. So the furthest 0 to the right here is at 4. So I know it's going to come in something like this. It's going to wind down, up, and then back down. Now if this would have been a -x cubed up here, I'd flip that whole thing. It would be, and I'll do it in green. If it was a -x cubed, then as x approaches positive infinity on this side, f of x would be negative, and it would look something like this. But that's not the case. So just showing you what would happen if it was a -x cubed. Let's get rid of this. And a couple things here that tells us we know what our end behaviors are. We decided that this is going to be positive as x was approaching positive infinity. Okay. So as x is approaching positive infinity right here, f of x is also approaching positive infinity. And you can see on this side, this is where x is approaching negative infinity because it's the left-hand side. Our end behavior is going down. So that would be negative infinity right there. Okay. So that's that. The only thing we need is our maximums and minimums. This minimum right here is between 1 and 4. You could do it by hand and kind of get a guesstimate. It looks like it's going to be right around and I'm not saying it's going to be exactly there, about 2.5. So you could plug 2.5 up in here with your calculator, evaluate it, and that could be your minimum. I'm going to use the graphing calculator here to find our maximums and minimums. So I'm just going to plug in the function there. I go to y equals, it's already at y equals, x caret cubed, and then arrow over. What is that? That is minus 4x squared. Minus 4x caret squared. Minus x and plus 4. Minus x and plus 4. And enter. I got to zoom usually to make sure I get that standard screen. I'll go down there to 6 where it says Z standard or zoom standard and hit enter, and there's our graph. I hope the graph is coming. There we go. Took a little while, but we got it. So now I want to find this minimum here. That's where you go into the calculate function on the second, and then calculate. And we're going to go down to, let's do minimum first. And you saw how we did this before. It says left bound in the bottom left-hand corner here in black above the X. I'm going to hit enter on the left-hand side, and enter on the right-hand side, and then just hit enter where it says guess, and we get 2.7 and negative 8.2, 2.78. So roughly, it's pretty close to 2.5, and if you put 2.5, that'd be fine. Our minimum is at x equals 2.8, and the minimum is roughly, you could say negative 8, but it's negative 8.2. You do the maximum the same way. Our maximum in this case should be, the calculator here. If you plugged in 0, it looks like it's going to be really close to 0. If you plugged in 0 up here in the function, you get 4. It's actually negative 0.1, which is about as close as 0 as you can get, and it's still about 4. So there it is. This is analyzing this graph. We found maximum, minimums, and behaviors, and we found our zeros given 1, 0. So this is what I want you guys to be able to do. Let's do another one here. This one's x to the 4th. Our leading term is x to the 4th. So graph the polynomial function f of x equals x to the 4th plus x cubed minus 4x squared minus 4x. There is no constant, so no number there. So that would be 0. We're going to put that in there when we do the synthetic division. They give us the 1, 0 at negative 1. Now, being this has a degree of 4, x to the 4th has a degree of 4. It should have 4 zeros. Sometimes it's less than that. They call it a double root, but we're not going to work with that today. It says find the other zeros, find the relative maximum minimums, and describe your end behaviors. Well, I can describe the end behaviors right now. I know that x to the 4th is positive and it's a degree of 4. So the end behaviors have to be going in the same direction. This would be a quadratic. If you follow this along right here, from one end behavior to the other, you're going down, that's one direction. You go around that turning point. Now we're going up, that's 2 different directions, so that's a degree of 2. So this would be a quartic, degree of 4. There's 3 turning points, 1, 2, and 3, 2 minimums, 1 maximum. If you follow it from this end behavior, you're going down, that's one direction. Go around the turning point, you're going up, that's another direction. That's 2, 3 directions, and then finally 4 different directions. This is going to be turning, this is a degree of 4. This is what our graph should look similar to when we're done finding the zeros and then put everything in. So I'll leave that there for right now. Well, let's just graph another little one. We know our graph should look something like this. It's a degree of 4. It should kind of look like a W. because the x to the fourth is positive. If the x to the fourth was negative, then my first end behavior would be going down, but that means both my end behaviors would be going down because it's an even degree. So they give us 1, 0, and that's -1. So that's the number that goes in the box. And then list out your constants and coefficients there, 1, 1, -4, -4, and 0. There was no constant, so we put that one in there. And then start our syntactic division so we can get our other zeros. I'll bring down that first number 1 and then multiply. -1 times 1 is -1. Adding the columns up, I get 0. -1 over there times the 0, I get 0. Add up this column. -4 times -1 is +4. Add up the column, you get 0. You could kind of quit there if you wanted to. -1 times 0 is 0. But this is our remainder right here. Our remainder is 0, so it divides in there evenly. Now, the degree of what we're divided into is x to the fourth. So this 1 right here is 1 degree less. That's 1x cubed. Plus 0x squared minus 4x plus 0, I guess, and then that's it. So we need to set this equal to 0 and solve or factor it first. Now, some people kind of freak out about this, but look at these two terms. They both have an x. Just factor that x out. I'd be left with x squared minus 4 equals 0. And I can't factor x again, but this x squared minus 4 is a perfect square. So is x squared. So this is difference of perfect squares. X and x for the x squared. For -4, well, it's going to be 2 times 2, but it's plus 2 and minus 2. If you were to FOIL this back out right here, multiply these two, you'd get x squared minus 4. So this is factored. Now, what are my zeros? The first one is this, x. Set it equal to 0, there's nothing to solve. You have a 0 at 0. X plus 2 equals 0, subtracting 2 from both sides. I get x equals -2. And finally, x minus 2 equals 0. We'll add 2 to both sides and you get x equals 2. So 2, -2, and 0. Let's go back up here. So zeros. First one they give us is x equals -1. We also found 0. I'll put -2 there. The first one, 0 they gave us is x equals -1. We had x equals 0, we had x equals -2, and we also had x equals +2. So those are my zeros right there. I'm going to plot those points. So -2, -1, 0, and 2. I know my graph should look something like this. So this last point here, when I graph it, the end behavior should be going up. And then just kind of weave in through there. We don't know exactly what our minimums and maximums are. We'll find those in a second. But we can fill in our end behaviors for sure. I know this because it was positive x to the fourth. My end behavior, that first one going to x is positive infinity, has to be going up. So this is positive infinity right here. You can see the other end behavior on the left-hand side as x approaches negative infinity is going up also. So they're both positive. Whenever it's an even degree, they're both going to be positive or they're both going to be negative. Okay? So let's plug in some 0 values here and figure it out. If you look at this one right here, I'm sure this isn't graphed perfectly. We could pull up the graphing calculator and figure it out, but I'm just going to show you how to do it by hand real quick. This minimum, relative minimum right here, is between 0 and 2, so it's probably going to be around 1. I'm not saying it's going to be exactly 1, but it's pretty close to 1. So if I just plug in 1 here into this function and evaluate it, that'll tell me what y is going to be. So we're basically finding f of 1 right now to find that relative minimum on the right-hand side there. So 1 to the fourth plus 1 cubed minus 4 times 1 squared minus 4 times 1. Let me move this down a little bit here. Get rid of this. Okay, 1 to the 4th is 1. 1 cubed is 1. 1 squared is 1 times negative 4, that's negative 4. And negative 4 times 1 is negative 4. Basically, this adds up to 2 plus negative 8, or negative 6. So really, we should have a point at 1, negative 6. 1, 2, 3, 4, 5, negative 6 right down there. So one of my relative minimums is that x equals 1 and negative 6. Is it exactly that? I'm not sure. I have to plug it into the graphing calculator to make sure. But this is a pretty good estimate. So if your graph looked like this, you would be fine. To find those other ones, just to make it a little bit quicker, we're just going to use the graphing calculator. I'm going to have to plug in a new formula there, so I'm going to clear that out. What do we got here? X to the 4th, caret key 4, arrow over, plus x caret key cubed, arrow over, and then it was minus 4x. Let me just go down here, hit the squared button, that's fine, and then minus 4x. Okay, enter. Let me see if I got that typed in there right. X to the 4th plus x cubed minus 4x squared minus 4x. Okay. So now I'm just going to hit, we'll just hit graph. It should be fine. A lot of times I hit zoom first. And there it is, going down to 6. So let's calculate. We'll find this maximum right here. There's only one relative maximum. You're going to do the calculate button, so second and then trace, that goes to calculate. Let's go to maximum here. Hit enter. Okay, it says left bound, so once again, you want to get on the left hand side of that maximum, that's close enough. Then left bound, right bound, it says right bound there. And once you get to guess, you hit enter again and it gives you an answer. So it looks like it's at about, maximum. X is negative 4.6. So I'd say, yeah, negative 4.5. Oh, that's close enough. And then 0.94. We can just say 0.9. So our maximum, I'll put it in red just so you can see a little bit, negative 0.46 at x, so I'd say negative 0.5, that's rounding it, that's close enough. 0.94, you could say 1, I'm going to say just 0.94, that's fine. Our other relative minimum, if you plug it in and find it, it's at about negative 1.6, and that minimum was at negative 1.5 or 1.4, pretty close. And there's our graph. This could be a little bit lower. 1.6, 1.45 would be right about here, so it should maybe came down to here. This one looks like it's pretty close to where it should be. So we analyzed this graph. We found our maximum, minimums, found our zeros by using synthetic division. If you can do this, you should do pretty well on the quiz. We have one problem left here. The average fuel in gallons consumed by an individual vehicle in the United States from 1960 to 2000 is modeled by the cubic equation. Cubic means it's t cubed or x cubed. In this case, it's t cubed. So our graph should look something like this. It's positive, so our graph, as x approaches positive infinity, our f of x should also be going up. So that's what our graph should look like. Where t is the number of years since 1960. So at 0, that's where 1960 is. And here's our graph right here. So right here at 0, this is 1960. So 10 years later, that's 1970, 80, 1990. This would be the year 2000, and this is 2010. So this graph is somewhat old. It says estimate the average or the maximum average fuel consumed and give the year that it occurs. So basically that's a relative maximum. And that's this point right about here. It's between 1965 and 1970. I'd say 1967.2, or we'll just say 1967. You could say 1968, and that'd be fine too. It's below 725 gallons per car consumed. I'd say 700, well, it's not 15, well, 700, I don't know, 12, 13, 14. I'll say 713 gallons roughly. That would be this point right here. Then the next question says estimate the minimum average fuel consumed and give the year that that occurs. Well, this is 1990, so I'd say this is 1992, 93. Say 1992. And that's just below 525. I would say 523 roughly. If you said 520, I guess that would be good too. But you can see where we've used maximums, relative maximums, and minimums in this type of a graph. So analyzing polynomial functions, and that's it. So peace out, Girl Scout. Have fun with the worksheet. If you have any questions, don't be afraid to ask me.